Okay, we are going to write in our composition book today. 1.2 is the section that we're working in. Let's make this a little bigger. Linear and rational equations. I'm just going to write the date. So whenever we have a equation, do y'all recall how to solve linear equations with one variable? To solve linear equations with one variable, your first step is to simplify both sides of the equal sign by combining like terms and or, so it could be both, or it could be just one of them, distributing or distributing. Okay, step 2 would be to collect all the variable terms on one side and all the constant terms on the other. By using inverse operations. So remember, whatever you do on one side, you have to do to the other. So I'm going to put in parentheses, keep balance. Then step 3, isolate the variable and solve. Step 4, check your answer by substitution. Check your answer using substitution. Okay, pretty much a review. So let's do a problem. So we'll do some examples here. We're going to do 15. This will be our first example. 15x minus 23 equals 2 parentheses 4x plus 20. Hey, I always draw a line down my equal sign just so I can remember to keep it balanced. So step 1, simplify both sides of the equal sign by combining like terms and or distributing. So we have to distribute that 2 all the way through. 15x minus 23 equals 2 times 4, 8x plus 40. And then usually the easiest thing you can do is move the smaller x to the other side. So we'll subtract the 8x from both sides. So that's an inverse operation. Positive 8x, negative 8x equals 0. So then we're left with 7x minus 23 equals 40. So using inverse operation, so we're going to get rid of this minus 23 and do plus 23 to both sides. So it's 7x equals 63. And divide by 7. So x equals 9. And the way we check it, we can use our calculator. So out to the side, write check. And then all you're going to do is every time you see an x, you're going to plug in a 9. So we're going to write down what we will put in our calculator. We don't have to work it out by hand. It's just writing down what we'll put in the calculator. So 15 times 9. I always put the variable or the solution inside of parentheses because it changes things whenever they're negatives or squares or something like that. That'll happen later on. And I put a question mark above the equal sign because I'm not sure if it is. Because if it isn't, then that's the wrong solution. We have to rework it. And if it is, then it's correct. So I'll do the left-hand side, and that's 112. And then do the right-hand side. And that's also 112. So if they're balanced on both sides, then that is the correct answer. All right, so was this pretty much a review? Y'all know how to do this? No problem? Okay, so we are going to do with rational equations now. So, and we also need to do the special cases.
Wait, are special cases like where they equal 0?
Where they equal all real numbers and no solution? Yes. Do y'all remember that?
Yes, and I suck at this so much.
So we'll have to do it again. So let's do the fractions. So rational equations. What we'll want to do is get rid of the fractions. We can clear the fractions. So I'll show you an example. Let's see. X plus 2 over 4 minus x minus 1 over 3 equals 2. Okay, so we want to get rid of the denominator, clear out the fraction. So what we do is we look at all the denominators. Since this is 2, that's 2 over 1. So what we want to do is find the least common multiple of 4, 3, and 1, which would just be LCM of 4 and 3. So think about multiples of 4. So multiple of 4 is 4, 8, 12. Multiples of 3, 3, 6, 9, 12. So our least common multiple would be 12. And we are going to multiply everything by that least common multiple. So we're going to multiply this times 12, this whole thing times 12, and this whole thing times 12. that means that I will keep this like this. Go ahead and put parentheses around the term that's the numerator. And this is going to help us get rid of that denominator because we have a 12 over 4 and then x plus 2. What does 12 over 4 reduce to? 3. So this is going to become a 3. So it's 3 parentheses x plus 2. And then the next one, minus, and then 12 over 3 times x minus 1. So it's 12 divided by 3. 4. So this will be 4 parentheses x minus 1 equals 12 times 2, 24. So now all we need to do is solve it. So on the left-hand side, we need to simplify both sides. The left-hand side is the one that we need to simplify by distributing and combining like terms. So 3 times x is 3x. 3 times 2 is 6. Negative 4 times x is negative 4x. And negative 4 times negative 4 is a positive 4. Equals 24. Then combine like terms on the left side. So we have 3x minus 4x. It's negative 1x. And then positive 6 and positive 4. So plus 10 equals 24. Subtract by 10 on both sides. Negative 1x equals positive 14. But our answer has to be written as x equals, so we change the sign on both sides, making this a positive x and a negative 14. And then we would plug it in to check our answer and plug it into the original. So I would do alpha y equals to give me that fraction. And you do negative 14 in parentheses plus 2 over 4 minus another fraction, negative 14 minus 1 over 3. And it equals 2, so that means we did it right. This time I didn't even write it down, I just checked it. Okay, so far so good. Y'all remember all this? If you don't, hopefully you are catching on pretty quick. Okay, let's go to the next page. Okay, let's look at cases when the denominator has a variable. So an example of this would be 1 over x equals 1 over 5 plus 3 over 2x. Okay, so in this case, we want the least common multiple of x, 5, and 2x. So we take the least x value, so we know the LCM will have an x, because that's the least, or maybe it's the greatest, sorry, the greatest x value. So if there was an x squared and an x, you do x squared. You always pick the greatest x. And then what about 5 and 2? That would be 10. So 10x is our LCM. So that means I'm going to multiply everything by 10x. And sometimes it's easy to simplify and then write it down. Sometimes it isn't. So I'm going to go ahead and just write them down and then we'll simplify. So this would be 10x over x equals 10x over 5 plus 30x over 20x. Is that right? 20? Why did I put 20? 2.
Oh, yeah, I was supposed to ask you that.
Silly mistake. Okay, so then this would simplify to just be 10 equals. This would simplify to be 2x. And the x's cancel here. 30 divided by 2 is 15, so plus 15. That makes it a much easier problem to deal with, just by getting rid of those fractions. So now we can solve it. Subtract 15. And we get negative 5 equals 2x. Divided by 2. Negative 5 over 2. Negative 2.5. Okay, so to check it, we would plug them in. So like 1 over negative 2.5 equals 1 over 5 plus 3 over 2 times negative 2.5. Question mark above the equal sign. So this one's already solved on this side, so I just need to do this side. One-fifth plus 3 over 2 times the negative 2.5. I wonder if I can make it a fraction. Yeah. But this is different, right? But what is 1 over negative 2.5? Math. Right. There we go. So negative 2.2 over 5 equals negative 2 over 5. So we did it correctly. Okay. Let's see about x over x minus 3 equals 3 over x minus 3 plus 9. Okay, so what is our common denominator? Or what is our LCM? What are we going to, this would be 1. These are the exact same, so we'll just use that. X minus 3, x minus 3. Since they're the same, that's your LCM. So you're going to multiply both sides, or every term, by x minus 3. So in this case, those will cancel, just leaving us with x equals, those will cancel, 3 plus 9 parentheses x minus 3. Then we have to simplify both sides before we start moving things around. So we're going to distribute the 9. So x equals 3. 9 times x, so plus 9x. 9 times a negative 3, negative 27. X equals, we can combine the 3 and the negative 27 together. 9x minus 24. minus 9x minus 9x. So negative 8x equals negative 24. And divide by negative 8 all the way through. So x equals positive 3. But whenever you have fractions, I forgot to do that on here. What can x not equal? Remember how we did that in one of the reviews about domain restrictions? What can the denominator not equal? 0. So what would make the denominator 0? So x cannot equal 0, which x was negative 2.5, right? Okay, what about this one? What can x not equal? 3. So what does that mean about our solution? It's no solution. So you're always going to have to check your denominator to see what would make our denominator equal to 0 to make sure you're not missing something, because this ended up being no solution. Okay, let's talk about conditional equations. So it's an equation that is true for at least, that looks bad. For at least one real number, comma, but is not the identity. So that's like the one at the top of this page. That would be a conditional equation, x equals negative 2.5. But an inconsistent equation is an equation that is not true for even one real number. So let's say an example would be like 2x minus 3 equals 2x plus 4. Whenever you simplify this down, you end up crossing out the 2x's. You get negative 3 equals positive 4. That is not true. So this is a no solution. Or it's like the example that we just did where x is equal to 3, but x couldn't equal 3. That's a no solution or an inconsistent equation too. And then identity is the last one. An equation that is true for all real numbers. So that'd be whenever you simplify it down, you end up having, let's say, 2x plus 4 that equals 2 parentheses x plus 2. All right, because if I were to distribute that, I get 2x plus 4 equals 2x plus 4, which means no matter what I put in for x, it's always true. So as an identity, which is all real numbers. Okay, so that is it for the notes. So you're going to work on 1.2 as your assignment.